Welcome to our second section in Unit 1, which is titled Math and Chemistry. This section is all about significant figures. Um, is very important as we are doing chemistry to be accurate in our measuring, and significant figures is what helps us to maintain that accuracy. Since we are talking about measuring, um, first we need to do a little background in how to measure and things like that. When we measure stuff in chemistry, anytime we do an experiment, we're most likely going to be measuring something, whether it's with a meter stick or a graduated cylinder, which measures liquids, or a balance, which measures mass. There's always going to be something to be measured. And it's very important that we do that accurately because it make sure that our results are accurate, right? You wouldn't want the guy making your, I don't know, soda to measure inaccurately. First, it probably won't taste as good. Second, it might actually be dangerous. You definitely don't want the person making your Tylenol to be measuring it wrong, because that could really be bad if he's measuring it wrong. So we always want to make sure these measurements are accurate, even when we feel like we might just be doing them in our lab at home. Accuracy is super, super important. So when we look at a measuring device, uh, the first thing we want to do is determine its scale. So we'll be looking at this graduated cylinder here today. You can see that curved line represents the height of the liquid. And then each of these marks represents one unit as we're looking at the scale. It's really important to check that out before you start using your measuring device, so you make sure you get the number right. Um, but you can see here we have 10 and 20, which are marked, and then the unmarked ones 11, 12, 13, 14, 15, and so on, right? Um, when you are reading your instrument, whether it's a graduated cylinder like this, a ruler, or a balance, you always want to go one number past the mark. So here, each mark represents one unit. So our answer is going to be one place past the decimal. Um, so we always have an estimation number. You'll see how that works here in a second. But you always want to estimate one number. So this is that same scale, up closer a little bit. We're going to read where the water level is. Um, so first we want to get the two lines that are closest to where our water is. This one you can see here is at 16. Again, when we count 11, 12, 13, 14, 15, 16. And the next line is at 17. But our watermark, you can see, is not on the 16 or the 17. It's in between those two, which is why we get a chance to estimate that next number for our answer. So the level is more than 16, but less than 17. So we have to estimate what that number in the middle is. Okay? So where our watermark is would be what? What do you think? So I estimated it at 16.5. To me, it looks like it's right in the middle. There's definitely an argument for if you said 16.4 or 16.6. You're also correct in that, because, like I said, that last number is you're estimating, because it's not exactly on the 16, it's not exactly on the 17. So we get to estimate where in between it is. Let's try another one. So again, first you got to check out your scale. And I got 3.80 because it's right on the line